All right. Hey guys, how's it going? This is going to serve as a lecture or just going over the finer points of motion graphs. And so let's go over some of these things. And I'm planning on making this into a play posit so you can go through it and answer the questions. So um, I think this is a very valuable tool to have to be able to look at graphs and um, kind of tell a story with what's happening. You know, are the numbers increasing? Are they decreasing? Are they expanding, contracting? Are they doing, at what rate? Are they getting, super fast or super slow? Or, you could tell a lot from a picture. And so um, looking at graphs is a very good tool to use. There's a lot of other uses for looking at graphs, from science to numerology, astrology, like all this crazy stuff. Um, but in physics and in science, you get data and you make a graph and you're supposed to be able to interpret it. So that's what this is about. So let's look at motion graphs, and we're going to be looking at distance time graphs. So this tells you where something is at what time, right? And so the main points here, time is always plotted on the x-axis. And here, let's see, if the object is not moving, a horizontal line is shown. So this object right here is not moving because it's a flat line. So flat line means something's at rest. That's the super important part there. Let's go to the next page. Clear, all right, clear, hold on, sorry. Then here we have an object moving at constant speed. So the distance is increasing, right? Distance is going up, right, over time. So as time goes on, distance is increasing. And since it's straight, that is a constant speed. So this is the main important part right there. Now, what if we look at two objects? So this is an important use of this. We can compare objects. Look, this one's faster than this one. How do I know that? Well, because the steeper the line is, let's see, do I have a spotlight? Draw. Nope. I have a highlight, spotlight. Let's see if that works. Steeper line, that doesn't work. All right, so the steeper the line has, they're both constant speeds, but since this one's steeper, it's faster, higher speed. That's the main point there. Now, so now we've seen an object at rest is flat. A straight line is a constant velocity. So then when we have a curve in the data, when this object is curving, it's increasing in speed. So we went from like a flat line, right, to a steeper line, right? So we got flatter, and then it got faster. So we know that this is an increase in speed, so this object is accelerating. So whenever you see a curve and it's important to know that it's a distance time, then that means that you have acceleration. If we just push this button. Nope. All right, so then this is just a summary. You guys can read over that. All right, so then we got some questions. So this is, hopefully I'm going to be able to put this in play pause and add some questions to it. Let's see. Which of the graphs shows that one of the runners started 10 yards further ahead of the other? Explain your answer. Okay, so I'm gonna give you 5 seconds, and you'll probably be able to stop it and answer the question. So 5. All right. So on this one, the answer is A. Why is it A? Because one started at 0 and one started at 10. So that means that they're 10 meters apart, or this is in yards, 10 yards apart. These two started at the same spot. These two start at 20. That's 20 meters. This one, they both started at 0, right? So, so this is the answer. This is 10 in there. I hope you got that right. All right. In which of the following graphs below are both runners moving at the same speed? So remember the slope of the line will tell us how fast they're going, right? The steeper the line, the faster they are. The flatter the line, the slower they're going. So if we have two with the same slope, then that'll be the answer. So this answer is D. All right. All right. The distance time graph below represents the motion of a car. Match the descriptions with the graphs. Okay, let's do these. Move this a little bit. Okay. So number one, which one of these shows that the car is stopped? And again, I'm just going to do this as a symbol. All right, so for number one, the car is stopped. Well, that is going to be C. No, is that right? Yeah, C is 1. So this is number 1. Number 2, the car is traveling at a constant speed. Remember we said whenever there's a straight line, the car is going at a constant speed. So I'm going to say A. Two, right? So whenever you see a straight line, even C is a straight line too. So it's at a constant speed of 0, right? So that counts there. The speed of the car is decreasing. So I'm going to say that one is D. See, it went from a very steep line to a flat line. So that's D. So that's 3 here. And then, yeah, then the last one, the car is coming back. That's going to be B. So some of these have 2. Let's clear all of that. All right, next. Okay, so the last one, I have slipped. So the last stuff we looked at was distance time graphs. So now we're looking at speed time graphs. So they're a little bit different. So speed, we know what speed is how fast something is moving. How is speed changing over time? Well, so in the last one, we saw that a straight flat line meant that the object was not moving, but that's different for speed time. A flat line indicates constant speed. So this is a constant speed. This is like maybe 5 meters per second or something, right? It's just going 5 meters per second. So that's an object that is moving at a constant speed. And let's see, hopefully we'll look at something that then we see an object that is accelerating. See, speed is increasing as time goes on. So we see a straight line and speed is increasing. And so it's accelerating. And then here we see speed is decreasing. So it's decelerating. So both of these show acceleration. Acceleration is happening here. When comparing to, what about comparing? So both of these are increasing in speed, but the solid one takes longer to get there. So they reach the same speed supposedly. Yeah, so the dash line shows a greater acceleration. So no curves on these. So the curve only comes out on a distance. And here we can see steady acceleration, steady speed, no acceleration. So whenever you see a flat line, that means no acceleration, and that's important. So constant speed. What they didn't go over was what does something look like that has no speed? So that would be a speed of 0, right? So if you're down here, he's not moving. He's got a speed of 0. That will probably be on the test. All right. Now a few questions. Let's see, where are we at? Time, 12 minutes. Okay, so this one, let's go through these. Which one of these shows a car that is stopped? So that's going to be H, I think. Sure, I don't want to give you guys the wrong answers. It's 8. There's 9. Okay. The car is traveling at a constant speed. Constant speed. I'm going to say G and H. Constant speed, that's 6. Constant speed of 0. All right. The car is accelerating. That's what speed's getting faster, right? Where is the car accelerating? That's going to be E7 and F. That means F, the car is slowing down. Speed is going down. So that's F, which is 8. All right. All right, so here are some more questions. All right, look at the graph above. So again, so this is a distance versus time. So this is not like the ones we were just looking at. This is from the first part. Which runner won the race? Explain your answer. All right, so which runner won? I'm going to say Albert. How do I know? Well, because he ran 100 meters in 12 seconds. So he did it the quickest. Which runner stopped for a rest? That would be Charlie. How do we know he stopped for a rest? Well, Remember, a flat line indicates that he stayed at that spot. So that means he's not moving, so that means he's resting. How long was the stop? I'm just doing that for a marker so I know where to put the question, or give me a little time. So how long was the stop? Well, it's here to here. So I'm going to say 13 minus 8 equals 5 seconds. How long did Bob take to complete the race? Bob took 14 seconds. Calculate Albert's speed. Figure the distance and the time first. Well, okay, let's move this thing. Oops. All right, so the last one. Calculate Albert's speed. So speed is distance divided by time. So how far did Albert go? 100 yards, right? Divided by, it's in meters. Gosh darn it. It's in meters. Divided by how long it took? It took him 12 seconds. So that equals 8.33. 8.33 meters per second. All right, last page. Let's clear that. All right, let's see. So here we're just supposed to say this is a speed. So this is the last thing we looked at, speed. So this only tells us speed. We have to say whether it's accelerating, decelerating, constant speed, or at rest. So O to A, O to A, O to A is from here to here. What do we know? Speed's increasing pretty quickly. So you're going to say he's accelerating. From A to B, he's going at a what? He is at a constant speed. How about B to C? Not accelerating. Well, it is an acceleration, but it's negative. So he's decelerating. And then the final one, the bus from C to D, look, he's at a 0 speed for a little while, constant speed of 0. So he's really at rest. I think that's it. Thanks for coming. Oh, there's one more. Rest. Well, you guys get the idea. So now we've been through this. You did the thing. So now there's some other videos to watch and a little quiz to take. All right. Hope you had fun.